This is Unit 8's Notes 2. Today we are going to be taking a look at integrals that yield an inverse trig function. So we're going to kind of be undoing what we did yesterday. So yesterday we learned about the derivative of inverse trig functions. So today we're going to be going backwards. Okay? So let's begin by just taking a look at this function. I'm going to take a look at f of x is equal to arc sine of x over 2. All right, let's take the derivative. So this is what we did in our previous unit. So it's arc sine, so it's 1 divided by the square root of 1 minus the square of that argument, and the square of that argument is x squared over 4. And then we have to multiply by the derivative of that argument because we have to use the chain rule, right? So the derivative of that argument is 1/2. So this becomes 1 over, I'm going to move that 2 to the front, square root of, now inside this radical, I'm going to get a common denominator. So I'm going to add these two terms. 1 is 4 over 4. 4 over 4 minus x squared over 4 is 4 minus x squared all over 4. Now this radical is the square root of the numerator divided by the square root of the denominator. So this becomes 1 over 2 square root of 4 minus x squared divided by 2, because the square root of 4 is 2. These 2's will cancel out and we just get 1 over the square root of 4 minus x squared. So we just showed that the derivative of arc sine of x over 2 is equal to 1 over the square root of 4 minus x squared. Okay, this is all what we did yesterday, or in our previous lesson. So what would the derivative of arc sine of x over 3 be? Well, using our pattern, the 4 came from the square of 2, so we would need a 9 here because 9 is the square of 3, like that. What would the derivative of arc sine of x over a be, where a is any number? Well, this would be 1 over the square root of a squared minus x squared. Okay? All right, so what this tells us is the antiderivative of 1 over the square root of a squared minus x squared must equal arc sine of x over a. So the antiderivative of 1 over the square root of a squared minus x squared with respect to x must equal arc sine of x over a plus c. Many times you're not going to just have an x here, you'll have some expression involving x's here. So in that general case, you'll do a u substitution. So you'll have a u squared there. And so you'll need a du there. So this would be arc sine of u over a plus c. Okay? Now, in class, I don't have time to develop the equivalent integrals that yield arc tangent of u over a and arc secant of u over a. But on this video, I do. So I'm going to go through the way that we get the antiderivatives of functions that yield arc secant and arc tangent. All right? But if you're not interested in that, that's okay. You can fast forward this video, and then when you get to, just pause it when you see the results of this. Okay? So I'm going to write all of our antiderivatives in a little table here. And when you see that, just pause your video or go ahead and start watching from that point. Okay? So let's consider f of x is arctangent of, let's do x over 2 to begin with. Okay? Then f prime would be 1 over, it's arctan, so 1 over the argument squared, so x squared over 4, plus 1, right, times the derivative of x over 2, which is a half. Let's simplify this. This 2, again, I'm going to move out front. Okay? I'm going to get a common denominator here. So this will be x squared plus 4 all over 4. I can reduce the 2 and the 4, and it leaves a 2 down there. And then I can multiply by 2 over 2, and this becomes 2 over x squared plus 4. Okay? So we showed that the derivative with respect to x of arctan of x over 2 is 2 over x squared plus 4. Okay? Now, I'd like to change this. I'd like to multiply both sides by a half. And you'll see why. Because when we're looking for a more general form over here. So I'm multiplying both sides by 1 over 2, so 1/2. This 1/2 on this side, I'm going to bring inside there, okay? That's mathematically fine. So we get that the derivative with respect to x of 1/2 arctan x over 2 is 1 over x squared plus 4. Okay? So the derivative of 1/3 arctan of x over 3 would be 1 over x squared plus 9. I'm trying to simplify this. That's what I'm doing by getting rid of that 2 that was up here. So the derivative with respect to x of 1 over a, where a is any constant, of arctan of x over a is 1 over x squared plus a squared. Okay? So the antiderivative of 1 over x squared plus a squared with respect to x is 1 over a arctan x over a plus c. And again, in general, you're not always going to have a plain x here. You might have a 9x squared or something else there. So in general, you're going to be doing a u sub many times. So the equivalent with a u, I'm just replacing u with x. So 1 over u squared plus a squared du would be 1 over a arctan u over a plus c. And there's our next equation. Now let's take a look at arcsecant. Let's derive the antiderivative that yields an arcsecant. So let's take a look at f of x is equal to arcsecant of, again, x over 2. Okay? So let's take the derivative. So the derivative will be 1 over this argument, x over 2, in absolute values, right? Square root of the square of the argument, so x squared over 4 minus 1, times the derivative of the argument, because we have to use the chain rule, 1/2. Okay? Well, this 2 and this 2 will cancel out, and we're left with 1 divided by the absolute value of x times the square root of, inside here I'm going to get a common denominator again, so it'll be x squared minus 4 over 4. Okay? So we have 1 over this absolute value of x. This is the square root of x squared minus 4 all over 2, because it's the square root of 4 down there, multiply by 2 over 2, and we get 2 divided by the absolute value of x times the square root of x squared minus 4. Okay, so we have shown that the derivative of arc secant of x over 2 is 2 divided by the absolute value of x times x squared minus 4. Okay, to make this more general, I'd like to make this a 1. So again, I'm going to multiply both sides by a half, and that 1/2 I'm going to put inside here. So we get that the derivative of 1/2 arc secant of x over 2 is 1 over absolute value of x times x squared minus 4. Okay? So, and I could say this, I will say this, if we replace the 2 with a 3, what would that be? So we'd have 1 over the absolute value of x, square root of x squared minus the square of 3, which is 9, right? So we could put an a in there, 1 over a, where a is any constant, and this would be inside this radical x squared minus a squared. So the antiderivative of this yields that, right? I'm going to go ahead and put u's instead of the x's. So we have the absolute value of u times the square root of u squared minus a squared with respect to u will yield 1 over a arc secant u over a plus c. Now there's one little thing with the absolute values. Oftentimes they're not going to have the absolute values here in your problem. Okay? You're not going to see the absolute values here. But we do need absolute values over here to make these equal. Alright? And again, it has to do with the domain restrictions and the need for this to be a positive argument. Okay? Alright, so here are our 3 big equations. Our 3 big equations that we're going to be using here. So the integral of, the antiderivative of 1 over square root a squared minus u squared du. You need to get to where you recognize this. U will have x's in it, or t's, or some variable. U is your variable though. If u is in the back with a negative of this radical, this will be arc sine of u over a plus c. If there's no radical, and you just have u squared plus a squared down here, you need to recognize that that is arctan. U over a plus c, but remember we needed that 1 over a out front. Okay? And then the last one is when you have u times the square root of u squared minus a squared du, and you need to recognize that that is arc secant. And arc secant also has that 1 over a out front. And then we have absolute value u over a plus c. So these are our formulas. And I need you to know those. Okay? Gotta know those 3. So after we do a few of these, I think you'll know them. Arctangent, AP likes arctan a lot. Alright? So that one we see a whole lot. we see arcsine some on AP exams. Arcsecant is not as widely seen on the AP exam. You will see it on my exam, however. Okay? Let's take a look at some examples. Example 1. Let's say that we have the integral of 1 over the square root of 1 minus 4x squared dx. So when you see this integral, I need you to recognize that this is an arcsine. Why is this not just a u sub? If we tried to do a plain u sub on this, we would let u be what's inside the radical. Du would still have an x in it, right? And we don't have an x here. We don't have an x to play with. So we cannot do this u sub. This is an arcsine. So I need you to recognize that that's an arcsine. Okay? When it's an arcsine, I'd like you to come over, like we did a u sub, just come over and say, okay, this is an arcsine. And I know for arcsine, I need u over a. And now do a u sub. You're going to do a u sub, and then you're going to state what a is equal to also. U will always be the square root of your x's term here. So the square root of 4x squared is 2x. A will always be the square root of your constant over here. So that will be 1 in this case. Now we have to do a u sub. So this we have to find du because we cannot leave dx if we're doing a u sub, right? So du here will be 2 dx. So in place of dx, I'm putting 1/2 du, right? In place of dx, I'm putting 1/2 du. All right, that 1/2 I'm going to pull out to the front. And what's left is exactly my arcsine form. A squared minus u squared du. So let's just go to our answer. Instead of rewriting it with a's and u's, let's just go to our answer, because it's right there. That's what we're left with. So this will be arcsine u over a, so 2x over 1 plus c. We could clean that up here, but I think I'm just going to leave it like that. Okay? Number 2. The integral of 3 divided by x squared plus 2 dx. Okay, again, if we tried to do a u sub, we would have to let u be the bottom, and du would have an x in it again. Du would be 2x, and we don't have an x up here. So this is not a plain u sub. This is an arctan. I know it's an arctan because of this x squared plus a number on the bottom. So come off to the side, and it's going to be an arctan. What does arctan have in it? Arctan has a 1 over a, and it has a u over a, right? So go ahead and write it there. It'll help you to remember what to do here. U is equal to the square root of your x's term, so u here is just x. A is equal to the square root of your number. The square root of 2 is the square root of 2. In this case, du is just dx, so we can totally replace dx with du, and we are fine. We're good to go. We don't need a number out in front like we did in number 1. The 3 is not a problem. I can take that 3 outside, right? So this will be 3 times 1 over a arctan u over a plus c. And that would be a safe stop. For multiple choice, they would just put this as 3 over square root of 2. Okay, number 3. The integral of 1 over x square root x squared minus 4 dx. Okay? Alright, well, if we tried to do a u sub, we would have to let u be what's inside this radical. Du would be 2x. Do we have an x to play with? We do not. We have a 1 over x to play with, but we needed an x up here if we were going to do a plain old u sub. Alright? That x has got to be in the numerator, and we don't have it. So this is not just a plain u sub. I need you to recognize that this is arcsecant. Arcsecant has an x out here and the x squared term inside. Okay? So this is an arcsecant. So come off to the side, put arcsecant. And now say what we have to do with arcsecant. Arcsecant does need the 1 over a out front, and we need an absolute value of u over a for the argument, right? So I need to say what u is, I need to say what a is. U is the square root of that x's term, so u is just x here. A is the square root of the constant term under the radical, so a is 2 in this case. Du is just dx, so straight substitution for dx here. Now, think of it this way too. We've got a u here, and we've got a u squared there, so that's good to go. Don't need to manipulate that. So this is just 1 over a, so 1/2 arcsecant absolute value of u over a plus c. Okay? Example 4. This time we have the integral of 1 over x square root of 9x squared minus 16 dx. Okay? So again, we would recognize that this is arcsine. Okay? The derivative of the inside would yield an x, and we don't have an x on top to play with. So this isn't, I said arcsine. This is an arcsecant. Definitely arcsecant, because we have an x outside here, and we have this x squared term inside, and the x squared inside is positive. So definitely an arcsecant. So the general form for arcsecant has the 1 over a, and it has absolute value of u over a. U equals a equals. Let's start there. So what would u be? U would be the square root of the x's term under the radical. So u would be 3x. A would be the square root of our number term inside the radical, so a would be 4. Okay, before we go and do du, which we're about to do, before we go do that, we have a problem, because this is now u squared, which is good. This has got to be u. Is this u? No, it is not. This is not u. This is just an x. So to force this to be u, we have got to make that a 3x. But we can't just go and stick a 3 in there. We have to also stick a 3 on top. Now it's in the right form, right? Now this is u square root u squared minus a squared. Okay? All right, now let's come and finish our du. Du is 3 dx. Look what we have up here. We have a 3 dx. There's our du. So if we were to write this, and you don't have to write this, but if you were to write this all in a's and u's, we would have 1 over u square root u squared minus a squared du. Okay? So there's no need to make another 1/3 out front because we needed that 3 up on top. There was an example that we did yesterday in class, and I said it would be good if you remembered what happened there. And I don't have it in front of me anymore, but it was this one. It was this one, where you had just an x outside in your answer. You had just an x outside, but you had more than x squared right here. Okay? So this is going to be just 1 over a arcsecant absolute value of u over a plus c. That's it. Example 5. Antiderivative of sine x divided by 7 plus cosine squared x dx. Okay. Again, it's key that you recognize that we have a number plus something with x's squared in the bottom. Okay? This is actually an arctan. Has to be. I'm going to come off to the side. It's an arctan, and arctan needs a 1 over a, and the argument of arctan needs to be u over a. U equals a equals. U is the square root of your x's term, and the square root of cosine squared x is just cosine x. A is the square root of 7. What is du? The derivative of u, the derivative of cosine x is negative sine x dx. So I can move the negative over. In place of sine x dx, we just have a negative du. And then we have a squared plus u squared, and then that's arctan form. So this is going to be negative because of that negative du. 1 over a arctan u over a plus c. Okay, number 6. Antiderivative of 5 dx divided by x square root of secant x squared, 16x squared minus 5. Sometimes you'll see problems where they put the dx up in the numerator. And don't let that bother you. It's the same thing as it being on the side. It's the exact same thing. Okay? This 5 that's up here is not at all going to factor into our process because we can totally take that outside. Okay? So what's left is exactly an arcsecant. It's an arcsecant. So the form for arcsecant has a 1 over a out front and an absolute value of u over a for the argument. U equals a equals. U is going to equal 4x. A is going to equal square root of 5. Okay, for arcsecant, be careful because we have to force there to be a 4 here. We have to. It has to be u there. This has to be a u. This has to be a u squared. This has to be an a squared. The 5 I'm taking out. It's not a problem. But I can't just come and put a 4 in there. I have to put a 4 inside as well, right? What is du? Du is 4 dx. So this 4 dx here, that is my du. The 5's coming out. It's not a problem. So I have du over u square root u squared minus a squared. All is good. So I'm going to have 5 that came out, and then I just go straight to my form here. 1 over A, arc secant, absolute value of U over A plus C. I love these problems. I find them a challenge a little bit, and they're just a little bit unusual. We're going to be getting into some different integrals and stuff, and it's fun to do these, I think. Okay, next up, antiderivative of dx over x squared plus 4x plus 13. Okay. So in this problem, the dx, remember, that's just like a 1 over this dx. Not a problem. All right. What do we have left after that? Definitely cannot use sub, because if we let u be the denominator, we're going to have x's in our answer, or we're going to have a 2x in our answer, and we don't have any x's up here. So it's not just a u sub. If I could factor the denominator, I would do a different process here, but I can't factor that denominator. Okay? This is a problem where we're going to force, it doesn't look like an arctan, but we're going to force an arctan out of this. I'm going to force there to be an x squared term, an x term squared plus a number in the bottom. The way I'm going to do that is we are going to complete the square on that. So let's complete the square on that. To complete the square, and I know it's been a little time since you've completed the square, here's what you do. Take your first two terms, okay? First two terms, the x squared coefficient has got to be a 1, all right? And it is here. Half of b, this is your b term from before, half of b, and then square it. Half of 4 is 2, and then 2 squared is 4, so we need to add 4 there, okay? But now this is different from what we had up there. I need to add something to make 4 plus that something equal 13. So I have to make that a 9, okay? You guys see that this is the same as that, right? Now we're going to factor these first 3 terms. When we factor that, it factors into a perfect square. I know it does because that's why we completed the square. So this factors into x plus 2 squared, and then we still have this plus 9. Now it looks like an arctan because it's x squared plus a number in the bottom. So it's an arctan. An arctan, recall, looks like that. So u equals a equals. U is what the x is being squared, the square root of your x's term down here. That's just x plus 2 here. A is the square root of the number, so that's 3. Du is just dx. So straight substitution for dx. So this is just 1 over a arctan u over a plus c. All right, let's take a look at example 8. In example 8, we have this antiderivative. So we have 3x dx in the numerator, and in the denominator we have x to the 4th minus 6x squared plus 13. All right, so let's take a look at this antiderivative. If we let u be the entire denominator, du would have an x cubed in it. We do not have an x cubed. So we cannot do just a u sub with u equal the denominator, right? We can't divide because the degree of the numerator is less than the degree of the denominator, so we can't divide. This limits our options. Again, I would take a look at this and say, okay, can I factor this? Because if we can factor this, I would go a different approach. We're going to learn that process in our next unit, okay? But right now, the only thing we can do is try to force an arctan with this. It doesn't appear to be an arctan, but let's try to force it, okay? If we're going to try to force it, then we're going to complete the square in the denominator. So this 3, not a problem. It can come out. The x has got to stay in. You never take an x outside of your integral. I have some students who try to do that. Don't do that. Leave it there. I'm going to write the dx to the side, which is where we usually see it. Okay? All right, let's complete the square in here. So to complete the square, I have x to the 4th minus 6x squared. I save the 13, and I complete the square on what I have. Half of b squared. Half of negative 6 is negative 3. And negative 3 squared is 9. So we add 9 to complete the square. But we have to add something else to keep our 13 value here, right? So we have to add 4 to keep our 13 there. Okay? Now we have in the denominator, take these 3 terms and factor. When you factor, you're going to get a perfect square. I know we are, because that's how we got the 9. That's what we did. That's the process. We completed the square to get a square here. That's why they call it completing the square. So this is something squared. Well, what is being squared? X squared minus 3. It's always the square root of this, and then it's half of this b value. Not half. Yes, half. Half of the b value. Okay? So that's that piece. And then we add 4. And now we see that we have an arctan. We have an arctan. Why is the x there? Well, the x is there to take care of our u, our du, actually. So it will be an arctan, and arctan has a 1 over a, arctan u over a. U equals a equals. U is equal to x squared minus 3. I don't know why I put parentheses, just x squared minus 3. A is equal to 2. So du here is 2x dx. Here's the x dx, which we have to have. The 2 I'm going to bring over to the du side and make it 1/2 du. So this is 1/2 du that's going in, right? 1/2 du is equal to x dx. So x dx is 1/2 du. This 1/2 I'm going to take outside. So that's going to be 3/2. After that, we just have u squared plus a squared, and that's arctan. So 3/2, and then we have 1 over a arctan u over a plus c. For a multiple choice answer, they would just make that 3/4 arctan. Everything else would stay the same. That is nice. So integrals, you guys, integrals get to be very challenging, and it's always a lot of fun to see what we can do to evaluate an integral. Okay? We don't have a quotient rule. We don't have a product rule. You know, all we can do, all we really have is u sub. It's really all we have. That and the power rule. Power rule is really strong. Power rule is really valuable. But other than that, we really just have u sub. And that's what we did here to force an arctan. Okay? All right, I have one more example for you. Example 9. And that is this integral of 2 divided by the square root of negative x squared plus 4x dx. All right. So for this one, clearly it's not an arctan. Clearly, because we have that radical on the bottom. Okay? We cannot just do a plain u sub because the derivative of the inside has an x in it and we don't have an x up here. So it's not just a plain u sub. There's also no x outside, right? So it's not an arcsecant. Inside we have a negative x squared. Well, which is the thing that has the negative x squared in it? Where's the negative x squared? Negative x squared is arcsine. So we need to, instead of forcing it to be an arctan, we're going to force this to be an arcsine. All right? So, the 2, I'm taking outside. I don't want it in there, so I'm going to take it outside. Okay? Remember, you can take a number outside. You can never take an x outside or a function involving x outside. All right. So this negative x squared, the first thing we need to do to complete the square on this, I have to make my x squared term have a coefficient of 1. And right now, the coefficient is a negative 1. So I'm going to begin by factoring out a negative. Okay? All I did is factor out a negative. Now, underneath in that radical, I'm going to complete the square inside here. Okay? So what do I add here to complete the square? Well, half of negative 4 squared is 4. Okay? But I can't just come in here and add 4, right? What do I need to do back here? What do I need to add or subtract to keep the same value? And be careful. Since this plus 4 is in the parentheses, it's actually a negative 4. So I need to add 4 back here to keep the value the same as what we had up here. If you don't believe that, then multiply it all out and see if you don't get what we had up here. We do. We get that right back. Okay? So let's rewrite this. I'm going to rewrite this and I'm going to put this positive 4 out in front. And then we have 4 minus, and now factor. It will factor into a perfect square. We know it will because that's what we did to get that trinomial. This is x minus 2 squared dx here. Arcsine. A number squared minus x's squared. So now it's arcsine. And arcsine, remember, arcsine does not have the 1 over a out front. It's just u over a. Arcsine of u over a. So u will be, and a will be. Well, u would be the square root of this, so that's just x minus 2. A would be the square root of 4, 2. du is just dx, so we don't have anything else to multiply by. So this will be 2 times just arcsine of u over a. Arcsine u over a plus c. So as a multiple choice answer, they would just remove those brackets. They might put parentheses here. Okay? All right. Love this stuff. This is so much fun. We get more and more complicated integrals, and it's fun to see what you can do to evaluate them. So each of these involved making it into an arc sine or arc tangent or an arc secant. Okay? All right. The more you practice, the easier this stuff gets. So you have got to practice. So go and practice.